Hi, welcome to another Level 2 coordinate geometry video. We're going to chat about parallel and perpendicular lines. So here's 2 points, S and R, and we're going to draw a line between them. Now a parallel line is a line that does not get any closer or any further apart than the first line. So a parallel line stays the same distance apart as our first line. But a perpendicular line does cross through the first line, and it meets it at 90 degrees or right angles. So perpendicular means meeting at 90 degrees or at right angles. Now, if we took the gradient of this first line, we know the gradient rises up 2 and runs across 3, so it has a gradient of 2/3. Well, if we just took a parallel line, it's going to have the same gradient, 2/3. But if we took a perpendicular line, it doesn't have the same gradient. Notice in this example, it rises down 3 and runs across 2. So we're going to write the gradient as -3/2. It drops down 3 and rises across 2. So there is a connection between working out the gradient of the first line and the gradient of a perpendicular line. And hopefully you can see a really quick trick. We swap the 3 and 2 over, and if it was positive, we make it negative, or if it was negative, we make it positive. So let's go through some examples and see if you can pick up this trick. The gradient of the first line is -4/7. So the gradient of a parallel line, that'll be the same as the first line. But the gradient of a perpendicular line, what we do is we swap the 4 and 7 over, and because it was negative, we make it positive. What about another example? What if the gradient of a line is 4, a whole number 4? Well, first of all, know that 4 is written as 4/1 as a fraction. Now, the gradient of a parallel line is still 4, but the gradient of a perpendicular line, we swap the 1 and 4 over to make it 1/4, and we make it negative because it was positive. So the gradient of a perpendicular line would be -1/4. Now, that's a cool trick, but it's not always easy to use when we get more complicated examples. So let's show you a proper formula that we're going to use to work out the gradient of a perpendicular line. We're going to call the first line, the gradient of the first line, M1, and we're going to call the gradient of the perpendicular line M2. And here's the rule, M1 times M2 is always equal to -1. The gradient of the first line times the gradient of the perpendicular line multiplies to get -1. So let's go through a couple of examples. Here's our first example. A line has a gradient of 2/5. What's the gradient of a line that's perpendicular to this line? Now you could use our cool trick at the start and just swap the 5 and 2 over and make it negative. But let's show you the proper formula. So M1 times M2 is equal to -1. So M1 is our gradient of our first line, which is 2/5, and M2 is the gradient of the perpendicular line. Now, what we're going to do is divide both sides by 2/5, and we're going to get our 2/5 on the left, or both cancel out, and we're going to get M2 is equal to -1 divided by 2/5, and we end up with our answer of -5/2. Now, it probably was a bit easier to use our little trick we learned at the start for that example. But let's look at another example where it's not so easy. A line has a gradient of 3.5. What is the gradient of a line that is perpendicular to this line? Well, now we're going to use our formula. M1 times M2 is equal to -1. So 3.5, which is the gradient of our first line, times M2 is equal to -1. So let's divide both sides by 3.5, and let's cancel out the 3.5s here. So M2 is equal to -1 divided by 3.5, and that gives us the decimal of -0.286 rounded to 3 decimal places. That's the gradient of the perpendicular line. Now this decimal is equivalent to the fraction of -2/7. And some of you might have been a bit clever because you would have realized that 3.5 is the same as 7 divided by 2, and then you could have used the first trick of swapping 2 and 7 and making it negative. Right, thanks so much for watching this video.